So when we look at this now, weak acids react in an equilibrium with water, and weak bases also react with water, and that's where the hydroxide ion comes from. So when weak bases react with water, one of the protons is transferred to the base. Most weak bases are molecular compounds that contain nitrogen. So we use the example of ammonia, and you remember from your introductory chemistry, ammonia has this Lewis structure where there's a lone pair of electrons on that nitrogen. So it can accept a proton the same way that we made that hydronium ion. So here we have ammonia reacts with water. It makes the ammonium ion, which is now dissolved in water, plus a hydroxide ion. So we've produced a hydroxide ion in water even though the compound did not contain the hydroxide ion. Okay, here we have diethylamine. This is another base, and it's got that nitrogen in there, so it can react with water to make this crazy species, the diethylaminium ion. You don't have to worry about naming those things in this class. And a hydroxide ion. So weak bases react with water and produce hydroxide, but the hydroxide actually comes out of the water. So now when we're looking at these, soluble strong electrolytes are written as ions in ionic equations. Solids are written as molecules in ionic equations. Gases are written as molecules in ionic equations, and weak electrolytes are written as molecules. So the only thing that gets broken up is things that dissolve readily that are strong electrolytes, and we write those as ions. Everything else gets written in the molecular form. Okay, so we're going to come back to writing ionic equations in just a few minutes. Before that, we want to look at the double replacement equations or metathesis equations. Now, I expect that you've all been exposed to this before. Do you remember double replacement, single replacement, decomposition, combination, talking about kinds of reactions in your previous chemistry? You remember hearing about them, even if you don't remember exactly what they are? So metathesis or double replacement happens when you have two compounds and they react to make two new compounds. So we have AB plus CD. Whatever these compounds are, they have ions in them, and they trade partners. So the cation A hooks up with the anion D, and the cation C hooks up with the anion B. We still write the formulas with the cation first and the anion second. And when we get metathesis happening, one of three things has to happen. A precipitate is formed, a weak electrolyte is formed, or a gas is formed. And the reason is that they are all reducing the number of ions in solution. That's what makes the real chemistry happen. So when you think about this and you're trying to kind of sort out how this is hooking up, I'll give you an everyday example. When I was in the 7th grade, my mother decided to torture me. So she signed me up for social dancing lessons. So on Saturday nights, I had to get dressed up in a dress and nylons with a garter belt. They hadn't invented pantyhose yet. And wear high heels. I still don't wear those today. And wear white gloves. They were ridiculous. And I had to go off to dancing class and learn how to dance. And they thought this would make me more socially acceptable growing up in the Chicago area. So I went to this class. I'd go in the first night, and our instructors were a married couple, Mr. and Mrs. Stromer. They were in their 40s. We were 7th and 8th graders. So we come in, and they tell us to come in and sit down. We're in the gymnasium at the high school. They had the bleachers partway pulled out so you could sit on the bottom row of the bleachers. So we walked in, and the girls all sat over on one side of the room, and the boys were all sitting on the bleachers on the other side of the room. And they would introduce whatever the step was for the evening. And then Mrs. Stromer would come over to the girls' side of the room. We'd all stand up from the bleachers, and then she'd stand in front of us. and she would show us the proper frame, and we would all start following her, and we would learn whatever dance step we were doing for the evening. This is the box step. It's a basic 4-count dance step, right? That was the first thing we learned. And then over on the other side of the room, Mr. Stromer stood in front of the boys, and they did the opposite thing. So doing the opposite, you don't step on each other's toes. Then Mr. Stromer would say, after we'd practiced in line, "Go get 'em, boys." And the boys would run across and grab a girl off the bench, and we'd come out and dance. And you were supposed to be dancing around. You had to have a proper frame, holding your hands in the appropriate socially acceptable places. There was no leaning on each other, wrapping your arms around. No frontal contact was allowed, right? No resting your chest against theirs. But every once in a while, that would happen. Things would start to get cozy, and then this drove me crazy. Mrs. Stromer had this ridiculous little bell. She'd pick up the bell and go ding, 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 ding. And when that happened, you had to stop what you were doing when all this frontal contact was happening. And you had to stop, look around the room, and trade partners. So let's say that I'm dancing with Rob, right? He might be a good dancer. You don't know, right? And Caton is dancing with Riley. They're getting friendly. So ding, 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 the bell rings. They have to stop that behavior, and then we trade partners. Now I've got Riley, and she's got Rob. You see how that works? So when we look up here, you've got A and B are dancing, and C and D. We stop and we trade partners. So we can think of metathesis or double replacement as trading partners at the dance. So we're not making new compounds. We are just taking the ions that are in solution and we're switching them up to trade partners. That's all that we're doing in double replacement chemistry.